So first of all, I would like to thank everyone for joining our session today. And today we have a special guest, Sergius, who is working in the Netherlands in our team in the field of the data science. And our topic today is exploring Databricks and Delta Lake. So first, let me give you a quick overview about the community, and then I will give you the stage, Sergius. Okay. To give you a quick overview, let's start with the code of conduct. So please unmute uh, all the sessions. You should mute yourself and then unmute yourself when you want to speak. And get unmuted back. And also, all session is recorded, so if you don't like to be recorded, I will kindly ask you to leave the session. For the rest of the code of conduct, you can review that on our GitHub page. To just give you a quick overview about Cloud DevOps Vision. So Cloud DevOps Vision is an open source community that believes in open education, which offers several activities that empowered by Microsoft MVP's members and Microsoft Regional Director. So we deliver several services like live streaming, also mentoring and open source projects, study groups, and also job recommendation, and all of that is a part is free. And the community is co-founded by three MVPs, live in several or different continents. So to just to give you a quick overview, it is very important to review the prerequisite, for example, like the code of conduct and the fact, like for example, if you would like to understand where you can find the session, where you can find the video, where you can find the slides, all of this information will be exist in the code of conduct and the fact, and also all the session will be on the YouTube. So just review the code of conduct on the GitHub, and you will find most of your question or answer for your question. We really appreciate your help and support for spreading that for the community. And again, we have several links for our community, either for the website or the GitHub or the Facebook, so you can follow us for several links. And to just to give you an overview about one of the activities that in Cloud DevOps Vision is Easy App, which is a very small web application that use several technologies. And in this application, we try to take this app and implement the end-to-end DevOps practices, including build, code, test, package, and so on. So this is one of the very important projects in our community, which cover, as I explained, the end-to-end. This, of course, including the planning, tracking with several activities, develop and test, including all like unit testing, version control, build, and so on. Also the release, like automatic testing, integration testing, load testing, staging environment, as well as monitoring and feedback. For our numbers, just to give you an idea about our community, we almost now exceed 1,100 members from more than 40 countries. And again, I really believe that this community should like we using these numbers or this community so we can, having several activities, not just a session, but we can have COP or COE, open source study groups, So it is very important to keep connected with our community so we can get, benefits from that community. Again, keep it connected. You can connect with several ideas by filling the survey or connecting to the GitHub by like our project or fork our repo. Try to suggest some suggestion. Again, it is very important to keep connected. Again, you really appreciate your participation. Okay, that's it from my side. The stage is yours, Sergius.
Yeah, thanks, Mohammed, and hello to everyone. And thank you for joining. I think it will be a very interesting session. So at this point, what I will do to make my life a little bit easier is that I'm going to turn off my camera and share my screen. We can go through the presentation that we have, and after that we will have a demo. I think there are quite some things to cover. I hope we will be able to cover them all. Always feel free to ask questions, even though there will be like question and answer section by the end of the session. Um, so that's it at this point. Let me just do a little bit of rearranging here and share my screen. Give me one moment.
Sure.
Okay. Um, let's see how that looks like.
Yeah.
Cool. Just let me do a little bit of a trick here in order to be able to see my big screen. Uh, okay. I think you can see me. Sorry, you can hear me, and you can also see the screen, right?
Yes.
Awesome, great. So again, thanks for coming to this session. We're going to try to explore Apache Spark, Databricks, and Delta Lake. Now, before doing this, let me tell you a few things about myself and basically why I'm giving you this session. So, my name is Sergios Lalas. I originally come from Greece, but I have been living in the Netherlands, living and working for the last around 8 years. Currently, I am a senior consultant at Avanade. Um, my my educational background is on financial and management engineering. I'm also a Microsoft certified professional, mostly in several areas of data. And let's say my data journey is approximately 12 years old. On purpose here, I chose this very beautiful, in my opinion, picture. It comes from the book Designing Data-Intensive Applications by Martin Kleppmann. And in my view, it's like a little bit, it's a feeling that I have, and I'm pretty sure that it's shared with more colleagues that have worked in the world of data. It's a vast world, and there are so many technologies, so many terms, so many trends, and it's like a continuous journey. Things change pretty fast, technologies change, but sometimes also the main principles remain the same. So just to give you a little bit of information about my background and how I started and how I entered this vast continent of data. Back in 2008, 2009, when I finished my studies, I actually started working as a data scientist. And at this point, I had to mostly work with AI and machine learning models. Um, but for me, I was always kind of wondering what comes behind data science, because when you work as a data scientist, usually your focus is on working with algorithms, but let's say in the scope of big companies, there is a lot of work that needs to be done before somebody actually starts taking data and trying to feed them into algorithms and all this kind of things. So at one point I started switching a little bit from data science to data engineering in order to understand better what is happening there. And this is basically what I have been doing for the last, let's say, 7, 8 years. Um, Now, when it comes to the world of data engineering, this is a quite complex world, as I said, and there are many trends that existed, and some of them have changed. And some of these trends we're going to explore, let's say, a little bit further down the line. Now, a little bit on the agenda of this presentation. Again, Spark, Databricks, and Delta Lake, these are huge topics. I will make sure that by the end of the presentation, I will give you more resources in order to continue. But on this session, I will just try to capture, let's say, the basic things. And this presentation, I hope it will help people who want to enter the whole ecosystem to get a nice feeling and take the next steps. So basically we will start with presenting like the big picture, like why do we need Spark, why do we need Delta Lake, what is Databricks, and how these things are connected. uh, then we will take a small look into Apache Spark using Databricks, and I will explain why. Then we will have a little bit of look on the technology of Delta Lake. I just realized now, and apologies for this, a bullet is missing, the bullet which is maybe the most interesting one, the bullet with the demo. And after we do the demo, I will give you some recommendations, some things that I personally followed about books, about trainings, and all these kind of things. Now, I need to note here that for me, like Apache Spark, Databricks, Delta Lake, it's a huge ecosystem, and in order to master it, it requires a lot of effort because you need to understand a lot of things about data modeling, how internals of engines work. You have also to learn potentially several programming languages. So it's an ongoing journey. But personally, I think it's where the future is going. And of course, I'm not affiliated with the company by any chance. It's just that I admire what they have done, and I have worked with it during my projects. Um, and I think it's, I think it's where things will be heading in the near future. Now, before we move forward, or maybe no, let me make some points as we move forward. So let's start with the big picture, and let me start with the evolution of data management, to put it like this. To begin with, if we make things very, very, very simple, um, what do companies want? Basically, every company has a mission, and companies do things, right? And all these things usually are captured into their source systems. Um, Many times companies want to understand things better, or to optimize things, or to understand the behavior of their clients. In other words, to get insights into their data. So in a very high level picture, basically they need to take out the data, to extract the data from their source systems, do something with the data, some transformations, some combinations, whatever, and eventually make meaning out of their data, either in a descriptive shape, for example, with BI reports, which basically show what has happened in the past, or by using some data science models in order to predict what will happen. But as you can imagine, business intelligence and data science are basically the two sides of the same coin, using your data to see what has happened and or what will happen. And the way that companies do that, it has evolved over the last year. So we started with this, and by the way, I need to mention here that most of the screenshots that I am using here are from some books that I will share by the end of the presentation, some awesome books. But to continue on this, maybe most of you are familiar with this picture, basically with the technologies of data warehousing, which is something that started around 1980s. and it is even used even in the current date. Actually, this was my first touch point when I started working with data. Um, so in an environment of a data warehouse, what we have is basically, um, as I mentioned before, we have our operational data, for example, or some external data, which represents the operation of the company or some other things that are connected to this company. And what companies do, they have some ETL processes. ETL stands for extract, transform, and load, which means basically take the data out of these systems, clean them, transform them, combine them, whatever, and then make some meaning out of this data, like store them into some data warehouses or into some data marts, and then out of this, what is a data mart? A data mart could be, in a rough way, let's say a subset of the whole data that corresponds to, for example, a specific need or to a specific department or something like this. But it's something specific. And out of this, you can create some, for example, business intelligence reports, or you could do some other things. Now, um, this world, as we can see, it's quite old, but on the other hand, it's also quite mature. There are a lot of methodologies that have been developed on this world. For example, when it comes to data warehousing, you have several schools of thought. Many of you may know Kimball, Imon. You have several data modeling techniques that exist, star schema, data vault, whatever. And all these things are the result of years of research. Now, the problem with the traditional data warehouses is that uh, as we go into a more modern era, uh, the nature of data has changed. So nowadays we have our data is different. Our data is, for example, we have much more data. We have different types of data, which means that the variety, the velocity, and the volume that we get data is much different. And this is a point where the underlying technology of the traditional, let me put it like this, the traditional data warehouses that we had, for example, on-premise servers, like an on-premise SQL server or an on-premise Oracle data warehouse, starts reaching its limits. Even though there was many developments on massively parallel processing, still it's not able to capture all these types of data, all these volumes of data. Plus, it's very hard to scale, and not hard, but also it's not the most cost efficient thing. Now, um, all these needs, to put it like this, leads us to the next step of the evolution, which is the so-called data lakes. Now, let's think about data lakes. So basically, what happened is that as companies began to collect large amounts of data from many different systems, architects started to envision like a single system to house data for many different analytic products and workloads. Um, and actually, this was the point that they started building data lakes. Now, being an active professional at that point in time where companies started switching from data lakes from data warehouses to data lakes. And to be clear, when I refer for data warehouses, I'm referring mostly to the traditional one, the on-premise one. There was a big hype for data lakes, and I have heard many people, they were saying back in time that, oh, and data warehouses are dead and it's useless, and now we can throw all of the data into the data lake. And yeah, it didn't exactly work like this, because what happened is that, of course, it's really easy to start throwing all of your data into a data lake, but then it becomes really hard if you want to extract your data and do something meaningful with your data. So to put it like this, data lakes were amazing in terms of sheer power and storage capabilities, and they were much more flexible in terms of, storing data. On the other hand, something was missing, and the two main components that people were used to in the old world of the data warehousing was ACID properties, and I will explain what ACID is, and also um, the flexibility, for example, to do something useful with data, to do some modeling, to all these kind of things. Now, and this was the point where many companies started realizing that, you know what, our data lakes start becoming a little bit of data swamps. Um, and this solution, even though it was more powerful, it was not optimal. Um, I mentioned ACID and why ACID is very important. ACID is a term when we have to deal with data. It's about atomicity and consistency, isolation, and durability. What that practically means, without getting into many details, it means that, if you imagine all the transactions that you have in an ideal world, everything would happen in a serial way, one after the other. Systems would never fail, and then everything would be perfect. But in the real world, what happens is that you have many situations where systems fail. You have a lot of situations where transactions are happening at the same time. So this is the point where things can go wrong. And even though in the traditional data warehouses, ACID was a given, like for example, if you had an HR system and you knew that two people at the same time they are trying to manipulate the same data, it was a sort of a given that this is safe. Or for example, that if a system would go down in the middle of a transaction, when the system was up, it was a quote unquote given that your data will be there. But this was not the case with data lakes, and this was a little bit of a problem there. Now, many companies try to tackle this by having a sort of a multitude of a system. Having a multitude of systems, meaning having a combination of systems, like for example, use a data lake, and then on top of this, several data warehouses, and then on top of these streaming systems and all these kind of things. Now, this worked, let's say, but it's very complicated. It takes a lot of time to develop all these things. The learning curve is really, really high. You have many moving parts, so also the chances of failure are pretty high. But this was, let's say, an intermediate state. So the next step on the evolution, which is quite recent, and this is where we sort of standing now, it was the point where the new generation of data lakes or data platforms started to appear. And this is called, you may hear it with several names. For example, you can hear it as a cloud data platform. You can hear it as a lake house, and I know that this is a little bit of fancy terms, but if you can imagine what is a data lake, a data lake house or a modern cloud data platform, is basically what you would get if you would redesign the data warehouses in the modern world. Now that, for example, cheap and highly reliable storage is available. So basically, it's the next step of the evolution, and it combines the processing power and the abundance of storage that you have with data lakes, plus a lot of goodies that you have that you had with the older data warehouses, like the fact that you have ACID properties, the fact that you can do a lot of modeling and all these kinds of things. And this is what is basically Delta Lake. And moving to the next slide, now that hopefully we have a little bit of a picture of the evolution and why this is really important in the age where we have a lot of data and different data. We're going to move into Apache Spark. And why Apache Spark? Because Apache Spark is, let's say, one of the cornerstones as a technology for being able to build systems like that. Now, a little bit of a brief history of Apache Spark without going into many details. It's actually pretty recent. It started back in 2009 as a research project. At that time, Hadoop was basically the dominant paradigm when it comes to parallel processing and distributed computing. And at that time, two things were clear, that cluster computing had a lot of potential, but at the same time, Hadoop and the MapReduce engine made it both challenging and inefficient to build large applications. Just to give you a little bit of an example, let's say that you have a typical machine learning model, and this algorithm may need to make 10 or 20 passes over the data. And in MapReduce, which is let's say the compute engine of Hadoop, each pass had to be written as a separate MapReduce job, which then had to be launched separately on the cluster and load the data again. And as you can imagine, this is not very efficient. Plus, in order to handle these new types of workloads, engineers had to develop several different systems. Maybe you have heard of things like Apache Hive, Apache Storm, Impala, Drill, Mahout, and all these kinds of things. And each of these systems had its own API and specific cluster configurations. And all these things, they were adding to the complexity, to the operational complexity of Hadoop. Plus, it was a huge steep learning curve. It was a huge learning curve for developers who wanted to go into this technology. What Spark changed is that, of course, you can Google the differences between Hadoop and Spark, but if I could summarize them, Spark made the whole thing much faster by doing some key things, such as decoupling storage with compute. For example, in Hadoop, the MapReduce engine was tightly connected with HDFS, which is the Hadoop file system, while with Spark, the storage is independent. You can use for example, Azure Storage, Amazon S3, it doesn't really matter. Also, another thing that Spark did is that all these in-between steps that I described before in order to calculate something, let's say, with Spark it was possible to do it with in-memory storage, which was much faster. The whole engine of Spark, it was much more optimized, which practically means that Spark is much faster than Hadoop. And also Spark, because something that I didn't mention, the vision of Spark and Databricks, to put it like this, it's about unifying, and I will explain what that means. Unifying in terms of technology, but in terms of also in terms of different workloads. And what I mean by this is that, for example, Spark offers several APIs in multiple languages that the users can use to talk with Spark. Plus, different kind of teams. For example, let's say that you have an end-to-end project, right, which involves a lot of data engineering on the one side, and on the other side, some data science work. Actually, now people can work with the same set of technologies, to put it like this, which all this unification makes it much easier for developers to understand, to learn, much easier to maintain, and also much faster. Um, so later on, Databricks basically was founded in 2013, and Databricks started as a company basically by some of the people who were involved in that project. And without going into many details, later on we had several Spark versions. You can see the dates there. I'm just pointing this out just to show that um, it is a living thing and it constantly gets better and better and better. Now that we have a little bit of a picture of Spark and data and Databricks and how it is connected, um, um, let's examine a little bit what exactly is Spark and try to see how it works. Um, so if I would have to put it in one sentence, I would say that Apache Spark is a unified engine which is designed for large-scale distributed data processing on premises or in data centers in the cloud in a simple way. Now, let's see how it actually works. Okay, if I start with a simple example, imagine that you sit on your laptop, you have a single spreadsheet, an Excel file, or you are working locally with SQL Server, and basically you see a table on your screen. Now, if you go back, this table actually sits in the memory, let's say, of your machine or on the hard drive of your machine. It's on one spot. Um, what we do with in the world of big data, you cannot store massive amounts of data on one spot, on one machine. So basically, you have to distribute it in several machines. And this is what we mean by talking about a cluster. What is a cluster? It's basically a set of machines that your data is distributed to. So what we show here is that imagine that you have this, this table, and a little bit of the data may live in one part of the server of the cluster, another in another part, and there goes on. So it doesn't live on one place. We will go deeper into this with some examples so you can understand also how it works. Now, a question that pops is how do we talk to Spark? How do we communicate? How do we program? How do we do things? Um, I put two pictures here from the documentation of Spark. I will not go into many details. Maybe the key points that I want to emphasize, because as I told you, it's a huge ecosystem with a lot of things that you can do with it. But maybe the takeaway that you should remember is that um, first of all, you can communicate with it using several languages. So you can write R, you can write Python, Scala, Java, or even SQL, which makes it very, very flexible. Um, and the way that this works is that um, every time that you write, for example, that you use Python or Scala, this code is translated behind the scenes into Spark bytecode, which does like an abstraction between you and the Spark engine. And of course, you have the low-level APIs that you can write. If you are a hardcore developer, you can really go into the heart of the engine and do things with RDDs, which is the heart of Spark, the resilient distributed data sets. Now, most of the people, what they really do is using the structured APIs, meaning that if you want to load your data, you can load them, for example, into a data frame, into a data set, or you can put them into a SQL table, a SQL view, and simple as that, you write your SQL code or you write your Python code, and the optimization happens on the back end for you. And this is an important detail. If you write code on a structured API, the optimization is happening in the background. You don't have to do anything. If you go down the rabbit hole and you start writing in RTD code, you really need to know what you are doing, because at this point you are telling the engine not what you want but how to do it, and this is not recommended, let's say, for the majority of developers. Now, this is a little picture to demonstrate you how Spark works and how we can distribute work with Spark. So imagine that on the one hand you have one developer basically who is connected with his laptop, and he writes some code in order to do something. Let's say to select some data, to filter some data, to join some data, whatever. What happens at this point behind the scenes is that all these commands, let's say, are directed into the Spark cluster, which is comprised roughly from a driver, which is basically the node which is the first point of contact, where the node which receives the commands of what it should do, and the workers, which is basically the actual workers which do things. And of course you have some other things like the cluster manager, but if you work in a managed environment like Databricks, it's something that maybe you shouldn't worry too much. So I will explain a little bit more about the ways of working with Spark a bit later on. But what you should keep for now is that if we focus on the executors, these are basically nodes. These are basically virtual machines that do something, and they have their own processors. They have their own memory. And if we move a step down, we can see a little bit how this works, right? And how this works is that imagine that starting from this side here, you have your data sitting on your data storage, and when you do something with this data is spread across the workers, and basically, let's say that if this worker is comprised of 4 cores, every core takes a part of this data, a partition as we call it, and does something with this. So this is a nice way to see basically how work is distributed across workers and how parallelism is achieved, which is a key thing. This is what we really want in the world of big data. Now, of course, it's not as straightforward always as it looks in this picture, because there are multiple times where, for example, in this picture here, you see a very clean picture where every core has one set and everything looks nice and tidy. But there are some times that in order to achieve something, you have to shuffle these little partitions among nodes. Let's say that this one should go there and that one should go there. And if you haven't done, let's say, a careful work on how you will program that, you may end up with shuffling, which is one of the biggest performance issues, let's say, in Spark, where basically you have a lot of data traveling from node to node in order to rearrange and give you what you want. Um, I will give some examples later. Of course, it's one of the huge topics. It's a topic that, you can read a whole book about. So I'm not going to go deep, but I'm going to give you some examples later on. Now, if we try to imagine how Spark works in terms of, of the jobs that it does, we can break it down like this, that the driver that we have creates a number of jobs, and each job has some stages, and each stage has some tasks. So this is how it breaks down. And if we talk, for example, if we focus a little bit on the stages here, this is because not all operations can happen in a single stage. So, maybe Spark will divide them in multiple stages. And then each stage, it's comprised of multiple tasks, which is basically a unit of execution. Um, and each task maps to a single core and works on a single partition of data. It's basically what I explained here. Um, if I give you an example, for example, let's say that you have a node, you have an executor with 16 cores. Um, this one can have 16 tasks working on 16 partitions in parallel. And again, this is how it's becoming obvious how highly parallel Spark can be. Um,
Sorry, Sergius, you come on mute.
can you still
Yes,
hear
yes,
me
now I
now?
hear you.
Okay. I don't know which was the part that I went on mute. Did you manage to hear
Yes, just the
this
last
slide?
part, yes.
Okay, cool. So yeah, sorry about this. I'm not sure
No,
what
no
happened there.
problem.
All right. So um, moving to the next step, now that we explained what are the jobs, the stages, and the tasks, um, moving a step further, um, when Spark works, um, many things happen, and some of the terms that you will most frequently hear are transformations, actions, and lazy evaluation. And all these things may sound very, very complicated, but I will try to give you a small example just to understand. So imagine that you load some data, you have some data somewhere in some sort of storage, and you load them. You load them into a data frame. And then you want to do something with this data, like you want to, let's say that you have a data frame that contains the names and the salaries of your employees, and you want to filter it. For example, you want to get the salaries of the employees who are, let's say, older than 30 years old. So you do something with this. Now, the data frames are immutable, which means you cannot modify a data frame. What you actually do is that you create another data frame. So if I have my initial data frame, which has all the employees that I have, and I want to take the employees that are, let's say, older than 30 years old, I will create a new data frame. And this is one of the transformations that we can do here. Um, now, the transfer the this is one of the this is one of the nice things of Spark. Um, all the transformations are evaluated in a lazy way, and what that means is that, going back to the example, I mentioned one transformation, right? That I had my initial set with my employees, and I just wanted to isolate, to filter the ones that are older than 30 years old, if I remember. And then let's say that I want to do something else on top of that. Then I want to get, for example, also a sum of the salary based on one aggregate, or I want to do something different, like multiple steps. Like each and every step will be a transformation that we will be doing. But Spark will not execute each and every step until the point that I invoke an action. And this allows Spark to optimize the execution plan. And what is the difference between a transformation and an action? It can be highlighted in this particular piece of code here. Just a little note, you see a snippet in Python and you see a snippet in Scala. And this is basically, you see that it's the same code. And this is what I was talking about before, that about the concept of unifying workloads. This is a nice example. You can use Python, you can use Scala, and the code is pretty similar. But okay, if we focus a little bit on the Python part, let's say that we have a data frame here that we call it strings. And what we do on the first line, we just load one text file. So at that point, we tell Spark to load this data here. Now, Spark will not load it yet. It just knows that it has to load it. Then we say that create another another data frame. Do one of the transformations that I was talking before, that out of this data frame that you have, just filter all the words that contain, for example, the word Spark. This is another transformation that we indicate Spark and we tell it what we want to do. Up until that point, Spark hasn't done it yet. But what Spark has done is that it has optimized the execution plan behind the scenes. And when we go to the third step, which is actually an action, so basically the first and the second step are the transformations that we're talking about, and the third step is the action, where basically we instruct Spark to give me a count of this word. And this is the point where Spark will actually execute the code, but it will execute it in an optimized way. So this is one of the nice things of the way that Spark executes code. You can read more about it. Again, it's a very big topic, but it's nice to keep in mind. Now, another thing, like we talked about the transformations before, another thing that you may run into are the transformations that have narrow dependencies and wide dependencies. What is the difference? The difference is that when a dependency is narrow, it means that in order to create one output, you need only one input. But if the dependency is wide, in order to create one output, you need multiple inputs. And the best way to explain this, because this is the case when we have wide dependencies. If you remember before, I talked about one of the major performance issues with Spark, which is shuffling. This is the point where things may go wrong. So imagine that I have a data frame where I want to select my data, and I have some data, and for example, let's say that this is my data, that my data lives in 3 nodes, and I want to select data where age is 37, right? I just want to filter data. Now, in order to do this, the engine basically has to go through each node, because, I mean, each node has its own engine, right? Because it has its own processor, but the processor can understand that, okay, I just want the age, the data where the age is 37, so it doesn't have to look elsewhere apart from what he has there. So from this node, he will just pick these these 2 rows. From this node, it will pick this row, and from this node, it will pick this row. That's it. each and every node worked in an isolated way. So node 1, in order to pick the data where the age was 37, didn't have to look on what's happening on node 2, right? Because it had all the information that he wanted. And then when we had the data from 3 nodes, we could, let's say, unify our data and have our final result. Now, if I had run something like select data, order by age. Now, you can imagine that if we want to have a unified result in the end of the chain, which is ordered by, it's not enough that each node looks on its own world, because you have several ages across nodes. So basically you want to have the big picture, right? And this is the point where data will start shuffling between nodes, because, for example, the transformation that you have is wide. This is a rough example. It's not the best way to say it, but just a rough way to have a feeling of what is the difference between a transformation which is narrow and one that is wide. Now, these are the basics on the transformations and on how Spark works. Of course, there are a lot many things, but it's. I will make sure to give you some resources that you can read further. Now, if we move to Delta Lake, which basically it's basically one technology that allows us to do the things that I mentioned before, that it's based on Spark. Um, let's say, what is Delta Lake? So in a very simple way, Delta Lake is a technology for building robust data lakes, data platforms, and actually it's a component of building these platforms. Uh, I will not stand here for a long time. These are the things that I mentioned before. Delta Lake is specifically designed to work with Apache Spark. It's ACID compliant. It's designed for unifying operations that are batch and streaming. You can enforce schema. You can time travel, which means that you can go back to previous, let's say that you have a table and you do something wrong with this table. You can always go to previous versions of this table, which is a lifesaver in many times. And of course, you can do something that it was very easy to do with a traditional database, a traditional data warehouse, like an upsert and an update, a merge, delete. But these things, especially when it comes to to upserts and to merges, it was a bit complicated with um, traditional data lakes. And this may remind you of a traditional data warehouse architecture, but actually this is also how things work now with Delta Lake. So basically, you can have your streaming data, you can have your batch data, and you can unify them in a sort of an architecture where you have your staging layer, where basically you put the data in, and then further across the line you refine your data in several layers. And in the end you have your gold layer, where basically you can source your reports, your data science models, whatever. Now, we are about to go to our demo. Before going into the demo, I will mention a point, like one question: how can somebody can use Spark? And there are multiple ways. There is the managed way and there is the unmanaged way, meaning that if you go the unmanaged way, you have to install a lot of things, a lot of libraries, many things. Personally, I prefer the managed way. So feel free to go to Databricks Community Edition and you can create a free account there, where you will have a small cluster that basically you can try things, and this is where our demo will be based at. Okay, so basically let's start with the demo. I will try to keep it short so we can have some time for questions. The demo was based actually on the documentation of Databricks. So I think it's one of the best resources to learn it too. So let me start this and let me move my window here. All right. So this is basically what
You
you
know,
get.
we have one
Yes,
question, if you don't mind, Sergius.
of course. Sure.
Kareem Abdesalam is asking how is Delta Lake is different from using Snowflake as a data lake and building the warehouse architecture using the DBT or data building tool.
You are referring to the Snowflake technology or to the Snowflake modeling technique?
Kareem, what you are referring to? Snowflake technology.
I'm referring to Snowflake, the data warehouse.
Okay, okay. Uh, to be to be honest with you, I'm not sure about the exact details because I didn't have the chance to work with this technology yet, but I can look into it and come back to you with that question. But I don't want to tell you something that I'm not sure about, right? So if you don't mind, I will come back to you
Sure.
on this question.
Thank you.
No worries. Um, okay, so going back to the example that we want to highlight here. So basically, this is what you get here. If you log into this Databricks community notebook here, what you see immediately is that you have your own workspace and you can create a new notebook. You can see your clusters, and basically this is a very small cluster that you are using. Um, and let me go back to where I was. And this is a notebook. Basically, with a notebook, you can connect several parts. Like in this case, I am starting with a SQL notebook here, which means that by definition, the language that I will be using is SQL. Um, of course, you can also write your um, markdown comments in order to decorate your code. Um, I was initially planning to run all of these things, but given the time that it's getting late, I will not run them. Maybe I will run one just to show you. If you want to run something, you can just point on it and, for example, either click this little button here or shift enter, and the code has run. What I want to emphasize here, and this is one of the important things, is that uh, I am in a SQL notebook here, but I can also run Python code. So what I did here with Python is that I just run a small Python code in order to import some libraries here. And what I do on the next step here is, again, I am running some Python code in order to import some data into a data frame. And then I can run some Python code again in order to show this data. I can also write some Python code, again, note the Python here, in order to do some manipulations with my data. For example, if I want to filter, let's say that I loaded this data, which is a table, which is a data frame containing some events. And I want just to filter on some of the events that are open. I can write this in Python, simple as that. Um, Also with Python, I can actually write SQL. So basically, if I'm more familiar with SQL, which is also the case with me personally, you can use this construct here in order to put your actual SQL query um, within Python, which makes it really flexible. Um, and moving a little bit forward, you can do basically the same thing using pure SQL, where, well, not pure SQL, it's Spark SQL, but it's very, very close. Like, for example, if you are a person like me who was working before with SQL Server, you will find that most of the things that you could do with SQL Server, you could do them with Spark SQL. Um, which makes a big difference with some other engines before Spark SQL, like USQL, that if you were coming for example, from T-SQL world, writing SQL queries was a bit of a nightmare because things were not working the way you would imagine that they would work. But just to close this parenthesis here, um, what I'm doing with these queries here, and maybe people who are more savvy with SQL will feel a bit more familiar, is basically I'm doing the same things that I did before. Using Python now, I'm doing them with SQL. And when it comes to Delta Lake, this is a little bit of the trick here. So basically, you can create a table, and just by using the part of using Delta, you can create a Delta table, which is basically a Delta table. Let's say it sits on top of the Parquet files that you have under the hood, which of course you can load independently into a data frame. But if you load them using Delta, you have all the goodies that I mentioned before. This is the big difference. And here you can see that after loading the data, I can actually write some select queries, just simple SQL. Yeah, I can also, for example, if I have jumping a little bit back to the data frames, if I had a data frame, an alternative way is that I could store it into a view, and I can query from this view here. And you can also do things, if you have your data, you can visualize your data, and this is really, really nice. For example, if I try to run this query here, my query runs, and it gives me this. From this point here, I can choose, for example, what kind of visualization I want, or if I don't want that, I can go back and yeah, you have a lot of flexibility on what you can do here, let's say. When it comes to the history, I will pass it very quickly because I know that we are out of time. But I mentioned before, for example, time travel, which is you can see the changes that you have done into your table. So this is very useful. Again, I know it's too many things. Also, many things are quite new to me too. It's as I said, it's a vast space, and I'm also still learning. What I would like you to keep from this from this part here is that keep the fact that you can go into the Databricks documentation, and this is an excellent resource to get some notebooks. To also, if you combine it with the community edition of Databricks, it's a very nice managed way to play with Spark and all these concepts without having to do the whole setup, for example, into your laptop. And if I go back to my presentation at this point to conclude, let's say, let me go here. Give me 1 second. So, okay, the last slide that I would like to conclude with is where do I go from here? Because it's too many things. It's a new technology. It constantly changes. So, what I would recommend you is to start with this book here, Learning Spark, and it's actually one of the books that I used in order to I borrowed, let's say, some of the screenshots that I used for this presentation here. You can also have a look on the Databricks Academy. It has several trainings, many of which are free, like this one here, How to Build a Cloud Data Platform. It's free. It's comprised of 8 hours of video plus some exercises that you can do and some sample notebooks. It's really nice. And of course, the documentation of Databricks, it's a very nice way to go through and understand things. Again, there are more technologies in the side, like many of you may wonder about Azure Synapse. And this is one of the usual questions that we get, what is the difference between Synapse and Delta Lake? There are many similarities, as you can understand. It's like there's a lot of competition, to put it like this, in this space at the moment. Personally, I haven't worked with other technologies in this space apart from Databricks and Delta Lake. So I cannot really give you a full, let's say, comparison, which one is best. And also keep in mind that the one that is best now may not be the best in a few years or in a few months from now, because things are changing pretty fast. But keep in mind that Databricks is actually founded by people who founded Spark, right? So for me, it's a sort of personal preference, and it's the point which makes the most sense. If I want to work with Spark or to understand Spark, it makes more sense to look at the company which is comprised of people who founded Spark rather than looking at something else. But again, there is no good or bad tool. It really depends on your infrastructure, your teams, your company, what you want to achieve, all these kind of things. So I think that's it. I hope I gave you a little bit of feeling of Databricks, of Spark, of Delta Lake. So let me switch back to my
Absolutely. This was very
camera.
interesting presentation. Thank you so much,
No
Sergis.
worries.
Um, okay, for people asking about the URL and the slides, I will share with that. Everything will be on the GitHub repo.
Mhm.
The Cloud DevOps Vision GitHub repo. You will find many repos for the live session and for the resources, which I will make sure that everything will be there. Um, Okay, and some of the question, and as you can see, is I think it is when you run the Python Spark, will it run on the on multiple nodes, or how this run?
So I'm looking at the questions. Okay, I'm looking on one question here. When we run Python in Spark, will it run it in multiple nodes? So yes, and when we talk about Python in Spark, we are talking about PySpark, which is basically the Python API in order to communicate to Spark. And this is the point, if you remember, that I mentioned that you write your Python code or your PySpark code, and then what Spark does is that it takes this code. For example, if you're writing a data frame using Python, Spark will take the Python code, it will convert it into Spark byte code, and it will do all the optimizations for you, and it will translate it basically into Spark code, and it will do all of the things that I mentioned about. So it's like an abstraction layer. You don't have to worry too much about optimizing it, assuming that you are working with a structured API, because Spark does it for you. Um, then I see another question here. If this platform has a built-in job scheduler that allows rerunning these notebooks every period of time, yes, it does. If you are in a production environment, you can actually schedule jobs. You can also do fancy things like not having a specific cluster, but um, create a cluster for your job and then drop it. And of course, also you can also version control your notebooks. Um, I see some other hands here. If I can share the resources. Yes, Mohammed answered. Any other questions,
Yes,
maybe?
I think there is some people are raising their hand. So please unmute
Sure.
yourself and just ask your question. We are in an open discussion where, so feel free to do that.
Can you hear me now, Mohammed?
Yeah.
Yeah,
Can you hear me now?
yeah,
Yeah.
Ahmed, yeah.
First, thank you for this session.
No worries.
Always, as I expect. with you. Always share the new knowledge and produce the new technology. Actually, this is an interesting topic.
Thank you.
I searched out for it for a long time. My question here: how can you use this new technology as a real case scenario if I am a very big organization and I need to analyze some of data? How can automate the cycle of this tool in our process? As you know, actually, as you see now, I write some of query and proceed some of query and output the result. But how can integrate it to deliver as a product or as a service? Can a top level of management can use it or can use the output for this tool?
Sure. So
My question: if a real case scenario was integration of the tool to output and show the benefit for it, I see now. Yes, we till now this is the new tools. This is the new technology. Some people know it, but the long goal is how can integrate this tools out. How can integrate it and how it benefits the business from
Yes, Sergius,
this side.
if you can give us like,
sure,
a sample real new case,
definitely,
yes, this will be useful.
definitely. So I will give you one of my maybe a real life experience, and it was the experience how I got to know actually Databricks and Spark. So some time ago, maybe a few months back or a year back, I started working as a consultant in one of the largest supermarkets of the Netherlands. In that supermarket, you can imagine that the environment of the data was huge. So they had a lot of stores across the country. They had multiple channels that people were shopping. Like, for example, clients could go into the supermarket and do a transaction there physically. People could also shop online and do the transactions virtually. Um, and eventually, when I started working on this project, um, the business, let's say, was using a part of this data in order to create some insights into their business. For example, they had a KPI dashboard where they could understand the behavior of their customers, and they could also use this data for marketing purposes in order to better target clients and all these kind of things. When I started working at this project, basically they were pulling data from a SQL server, and that SQL server, I don't know how it really started. Maybe on one point it was an on-premise SQL server, but later on they created a huge virtual machine having a SQL server. But of course, when we talk about transaction data that are millions per day, you can imagine that SQL Server on one point reached its limits. At that point in time, the next step is that they decided to stop using SQL Server and use big data technologies and all these kind of things. So they started using data lake analytics with USQL at this point, which is basically an older technology that now it's not supported by Microsoft anymore. The benefit with this technology that they had is that they could now load huge amounts of data. But the first problem was that they lost all the flexibility that they had. Like, for example, it was extremely hard for an analyst who was used to just connect to the SQL server and write some simple queries to analyze data. With the way that SQL was structured, it was extremely hard to do this kind of thing. So on the one hand, you had power, but on the other hand, you lost all the flexibility that you had to analyze data or to create some new feeds for new insights. And that was the point that we actually switched to these technologies that I just mentioned, Databricks and Delta Lake. and we replaced all of the infrastructure that was SQL based. We replaced it with Databricks and Delta Lake, and not only things became easier to maintain, faster to execute, and all these kind of things, but also at this point, a lot of different people had a unified platform in order to do things. Let's say that a lot of the ETL was happening using the same engine and the same UI, to put it like this, that data scientists or data analysts were using in order to run some ad hoc exploratory queries on their data. And I think that everybody was really happy that this choice was made. And of course, uh, when it comes, for example, to serve the data, yeah, there are multiple ways that you can serve data. Like in this case, for example, one of our end products, it was a dashboard based on Tableau. But of course, you can also serve the data with Power BI or with many other ways. So it's really unified. And as we speak, now there are some new evolvements that are happening, like SQL Analytics, which is a new feature. So it's constantly getting better and better. That's my opinion and my personal feeling. I hope I answered your question a little bit.
Yeah, sure.
Um,
Okay.
Thank you.
Okay, another question is, can we deploy Spark projects in multiple environments?
In multiple environments, I would assume, like, like in a DevOps cycle, test, dev, all these kind of
Yeah.
things. Um, Normally, Mohammed, I would leave this question for you because we have worked on this
Yes.
too much. But the short answer is definitely yes. If you want the longer answer, you can talk to Mohammed because he is our guru when it comes to DevOps, so he can give you a much better picture than I can.
Yes, just,
So.
normally it is like we have several environments, for example, test or pre-prod and prod and so on, and we promote the notebooks or the pipelines, the EDF or Azure Data Factory pipeline, which is, I'm usually still, with the part of the still with the data is a big topic, even for me. So yes, definitely we can deploy that to multiple environments.
Yeah.
Okay, so is there any other question?
Yeah, one other question about data loading. So how exactly is data loaded into that? Is this data lakehouse? Is it like with third party tools like Fivetran, or is there like a built-in connectors to like different databases and event trackers?
Right. So uh, what Databricks is trying to do is basically they are trying to minimize the need for third-party tools. This is the whole point of unification. Um, to put it like this, if I try to give you a little bit of an idea of how it really looks like, um, you can have an environment where basically you could load your data, again using data bricks from several different forms. For instance, you can have, let's say, a hierarchical structure that you have CSV files. You can have a structure where you have Avro files, and you can just load this data. You can also connect, if you have, for example, on-premise systems like an on-premise SQL server. You can create a custom integration runtime and just connect to this SQL server, for example, by using Azure Data Factory, and just pull the data in. Uh, the native format, the native format of Delta Lake and Databricks is Parquet. So basically, you can load your files. I mean, you can store them as you want, but most of the times, uh, all these technologies are based on Parquet format. Of course, you can store your data in a Parquet format and just load them. But if you combine them with the power of Delta Lake, again, it gives you the extra benefits that I talked before.
Okay.
I hope I answer your question.
Yeah, thank you. Okay, is there any other question?
Yes, I want to thank you all, especially you, Muhammad Radwan, and sure, our dear Sergis, for this wonderful presentation. I was just surfing the internet when I saw the link, and what caught my eye actually is the screenshot of data warehouse and data lake and cloud data platform comparison, as this is our fields of interest, as I'm a data engineer. So I hopped in, and I can say I didn't learn anything new. So thank you very much, and I'm waiting for the resources to be shared so I can learn more about Databricks and Delta Lake and how to benefit our company with them. Thank you.
No problem.
Thank you
Sure.
very
Thank you
much.
for your comment. Actually, and if you have, any question, I think this is the good opportunity. We have Sergius here as an expert. So, I mean, to take this a chance to, to get the question.
Well,
Yeah, yeah,
it's an
I know,
expert
I
that
know.
still I'm an expert that is still learning, right? So
Yes, we all
Yes,
we all learn.
we all still learning. Yes,
Uh,
yes, sure. No, no, I'll leave the place for others
okay.
to ask. I just wanted
Thank you.
to say
Thank
thanks.
you.
Thank you.
Uh,
no
okay.
worries.
It seems there is any other question, I think.
Yes, I have an technical question
Mhm.
regarding the data scientist role. We can imagine the working environment as a software engineer. You get the tasks somehow from the customer. It invokes you to add new feature. But for a data scientist, how you know what's the next step to do? Is it just for optimizing the work environment for the company, or I hope you get my question. What is يعني,
Yes, I
the
think you're
insight
asking about
from which you get?
yes, how you organize the work, as part of, if you can share, Sergius, part of your experience organizing the work, how, this part.
Yeah, so if I try to give you some examples, like if I put a little bit my data scientist hat, which is a bit rusted at the moment, but I will do my best. Um, let me put it like this. Data scientists or data analysts, one of the first things is that they don't know. They want to experiment, right? Because their work is not a sort of repetitive work, but it's a lot of research work. They have to innovate, they have to experiment, they have to basically start with exploring data. Um, and most of the data scientists are like, if I can summarize it, you have the data scientists that sometimes they're used to, for example, writing Python code, let's say in Jupyter nodes, Jupyter notebooks, by just loading some data there and trying some data science models. On the other hand, you have data analysts that usually are a bit more SQL savvy, and for example, they just want to explore their data in order to go to the next step. So this is exactly what Databricks can facilitate, that all these different people, they can use the same tool sets and they can look at the same data without having, let's say that your data is sitting, let's say on one layer of your data, right? Let's say that you have a company with some engineers who extracted some data from your source systems and they just landed them into your data lake. So both analysts and data scientists, they can connect using the same tool sets, tool set, to put it like this, in order to explore their data and figure and experiment with algorithms and all these kind of things, and go to the next steps. I'm not sure if I answered your question, but I think this is one of the aspects that shows how this work can happen. And this is also
Sure,
what
yeah.
I have seen.
Answer.
Cool.
Okay, so
Thank-
thank you. I don't want to keep you more serious for that. We are
No worries. No worries. I mean, if anybody has any questions, please feel free to ask.
thank you.
Thank you so much, Sergio, for the time and for your session. This is very informative. Thanks, Mohammed, for organizing this.
Thank you, Mohammed.
Really appreciate it.
Thank you.
Yeah. Thank you very much, guys, also for giving me the chance to refresh my knowledge of what I have seen like all these times, and share it with you. And of course, from my side, feel free to find me in LinkedIn. I think if you just Google my name, Sergio Slalas, I think I am the only one. And you will recognize the picture, so feel free to connect.
Thank you.
And if you have any other questions, just message me on LinkedIn, and I will be happy to answer, or with Mohammed.
Yeah,
And thank you, Mohammed, also for
that's a
organizing
great,
it.
Sergey. Really appreciate it. Okay, thank you everyone. And again, you will find any information on the GitHub. If you have any question, again, you can raise issue on GitHub. Feel free to ask your question there. And see you in the next sessions. Okay, great. Cheers.
Great.
Thank you.
Have a great
Have
day.
a nice
Bye-bye.
day, guys.
Thank you.
Bye-bye.
Bye. Thank you.